Welcome back to the channel. I am Undasan Worko, and today we are diving into the essential toolkit of right triangle trigonometry. Have you ever wondered how surveyors measures the height of a massive building without climbing to the top? It all starts with understanding how the angle of a right triangle connects to its sides. In this video, we are going to cover everything step by step. How to properly names your triangle sides, opposite, adjacent, and hypotenuse. Master the correct trigonometric ratio, sine, cosine, and tangents. How to use simple algebra to solve real-world heights and distance problems. The geometric secrets behind the famous identity. How to use inverse trigonometric functions to find unknown angles instantly. By the end of this lesson, you will have a complete blueprint to tackle any right triangle problems with confidence. Enjoyed this lesson? Like this video if it helped. Subscribe for more straightforward maths and science tutorials. Comment below with any questions about trig ratios or inverse functions. Trigonometry connects the angle of a right triangle to the length of its sides, which makes it useful for measuring things that are hard to reach directly. From a right triangle to forming sine, cosine, and tangent ratios to using those ratios for heights and distances, then to a basic identity, and finally to finding an angle from a known ratios. We begin with the side names because every trigonometric ratio depends on which angle is being used. This angle but is not the hypotenuse. These side names give us the vocabulary needed to build the trigonometric ratio. Now that the side names are clearer, sine compares the opposite side to the hypotenuse side, while cosine compares the adjacent side to the hypotenuse. In words, sine means sine of an angle is opposite over hypotenuse, and cosine means cosine of an angle is adjacent over hypotenuse. With sine and cosine comparing sides to the hypotenuse, and tangent compares the two legs of right triangle directly. Tangent of an angle is opposite over adjacent, while the three ratios available, a height or distance problem starts by matching the known side and the unknown side to the side of one ratio. If the angle and one side are known, the matching sine, cosine, or tangent equation connects them to the missing lengths. After the correct ratio is chosen, algebra isolate the unknown side while the trigonometric value comes from the given angle. The missing height or distance is found by multiplying or dividing, while that trig ratio depending where the unknown appears in the equation. While lengths solving in place, a real measurement such as a surveyor finding a building height can be modeled as a right triangle. The line of sight forms the hypotenuse or a slanted ray. The ground distance is one leg and the vertical leg height is the other leg. Once ratios are built from the sides, geometry explains why some trig statements are always true, because the legs and hypotenuse of a right triangle follows the Pythagorean theorem. Sine and cosine also have a fixed relationships. Using sine as opposite over hypotenuse and cosine as adjacent over hypotenuse, squaring both ratios gives opposite squared over hypotenuse squared and adjacent squared over hypotenuse squared. Adding them gives opposite squared plus adjacent squared over hypotenuse squared, which equals to 1 by the Pythagorean theorem. So sine squared on an angle plus cosine squared of the angle equals to 1. With the identity established, one ratio can help find another when the angle is the same and the triangle is right. If sine or cosine is known, the equation sine squared plus cosine squared equals to 1 can rearrange it to find the missing ratios. After using an angle to find a ratio, inverse trigonometric functions work in the opposite direction. An inverse sine, inverse cosine, or inverse tangent takes a side ratio as its input and returns the angle that produces that ratios. With a known ratio from the side lengths, the calculator uses inverse sine for opposite over hypotenuse, inverse cosine for adjacent over hypotenuse, and inverse tangent for opposite over adjacent. The result is the measure of the reference angle. While with ratios, applications, identities, and inverse functions connected, right triangle trigonometry becomes a complete toolkit. A problem can move from a chosen angle to side ratios, from side ratios to missing lengths, from geometric identities to related ratios, or from a known ratio back to a missing angle.